Hello, good morning, good afternoon, good evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra class. Today we're going to be talking about percent applications. We have three parts of percent applications. Percents are very important for mathematics and for just everyday general life. So I want to try to really do a good job explaining all the aspects of percents. So today we're going to deal with part one, and we're going to look at decimal to percent conversions, which I know we've already learned. We're just going to review it, and we're going to talk about the ever important percent change. So before we get into those two specified parts of percents, let's talk about what percents are. Okay, let's look at the meaning of percents. If you look at the word percent, it's really broken up into two Latin roots of per and cent. Okay, per means for every. One piece of paper per student. That means for every student. 3 slices per person. That means there's 3 slices for every person. $5 per person to ride the ride. That means $5 for every person. So per is for every. Per is for every. And cent, think of century. Okay, cent is 100. So when you put the two roots together, percent, it means for every 100. Percents are parts of 100. Remember when we talked about fractions, I told you that fractions, decimals, and percents are all the same thing, just written in different forms. Well, remember that a fraction is a part of one whole? Well, one whole equals 100%. So a percent, okay, is for every 100. It's part of 100. Okay, what part of 100 am I showing? A nice easy way to think about this is to think about pennies. Okay? There are 100 pennies in one whole dollar. One whole means 100%. One whole means 100%. So each individual penny is 0.01 or 1%. Why? Because it's one part out of 100 possible parts. It's 1 penny out of 100 possible parts. And you know how to turn this into a fraction. That's 1/100th. So you can just read it out, 0.01, 1/100th, or you can divide 100 into 1. You got a decimal. That's a 0. That's another 0. I'm sorry. That was wrong. Sorry. No, it was not wrong. Sorry for second guessing myself. And then you're going to have 1. Okay? And that was wrong. Sorry about that. It's 100 into 1.0. 100 goes into 10 0 times. Sorry, I shouldn't have tried to speed through it. See, that's what happens when you speed through things. And 100 goes into 100 one time. So 0.01, 1/100th. So pennies are a great way to think about percents. Remember, there's 100 pennies in one whole dollar. There's 100 individual parts in one whole dollar. So each penny is 1/100th or 1%. I hope that helps you start to understand what percents are. Now, unknown percents can be described as x over 100. That is the best way to represent an unknown percent. Why? Because whenever you divide by 100, you're moving the decimal 2 places to the left. And since you cannot work with percents, you always have to turn them into decimals. This is a great way to represent it. Okay? Now, let's talk about that whole percent to decimal conversion. You're never really going to work with percents. When I tell you 15% of 22 is what number? Okay, you have 15% of 22 is what number? Well, you're not going to work with 15% in the percent form. You're going to work with 15% in the decimal form. So what this is really going to turn into is 0.15 of 22 is what number. And now I can actually do the math. So let's talk about these conversions. When converting to percent, from percent to decimal, okay, when converting from percent to decimal, notice how I have a little red L there. You move the decimal 2 places to the left. So remember, we talked about this already. When going from percent to decimal, L, you go to the left. When converting from decimal to percent, think about the R and the T, you move the decimal place 2 places to the right. Why to the right? Because there's an R and a T in percent. So percent to decimal, L, left. Decimal to percent, R, T, that's right. 2 places to the right. Let's go ahead and practice a little bit. Okay, 6.5%. A lot of people get confused here. Well, I can't really turn a fraction into I can't convert this fraction like this percent like this because it has a fraction. So I have to convert that fraction into a decimal. And 6.5% would be 6.5%. How did I do that? Please remember that 1/2 becomes 2 into 1.0, and that's 0.5. Okay? Remember that when you're going from fraction to decimal, you simply divide. So 6.5% is 6.5%. Now I can turn that into a decimal. I'm going from percent to decimal, so I'm going to go 1, 2 places to the left, place a decimal, fill in the gap with a 0, so it's 0.065. Here I have 12.6 for number 2, and I want that in a percent. So I'm going from a decimal to percent, so I'm going to go right 2 places. 1, 2 to the right, place my decimal, fill in the gap with a 0, so that's 1,260. 0.753, I'm going to turn that into a percent. So I'm going to go to the right, per, RT, 2 places. 1, 2 to the right, place my decimal, so that's going to equal 75.3%. Okay? Please make sure you put the percent symbol when needed. 12%. Well, 12%, I'm going to go to a decimal. So I'm going to go 1, 2 to the left. So that's going to equal 0.12. 36.2%. Okay? I got 36.2%, and I want to make that a decimal. So I'm going percent to decimal, L, 1, 2 to the left. So I've got 0.362. 0.058 to percent. I'm going to go 1, 2 to the right. So I've got 5.8%. 4 2/3%. Well, 2/3. Let's first investigate 2/3. If you remember 2/3, you go 3 into 2.0, bring up the decimal. 3 goes into 26 times. And I'm going to have a repeating value here. It's going to be 66666 repeating forever. So the way we do that when we're converting a mixed number percent into a decimal is we round the repeating decimal to the hundredths place. So this in essence is going to be 4.67%. And now from there I got to go 2 places to the left. 1, 2. Fill in the gap with a 0, so I've got 0.0467. And last but not least, 0.0005, or 5, tenths, hundreds, thousands, 10 thousandths. I want to turn a decimal into a percent, so I'm going to go to the right 2 places, 1, 2 to the right, so it's going to be 0.05%. Okay, that should have been pretty easy. Hope you enjoyed that part. Now let's talk about percent change. Okay, my friends, for percent change, when we're talking about percent change, it describes the percent increase or decrease from one old or original value, okay, to one new value. If the percent change is positive, it is a percent increase. If the percent change is negative, it is a percent decrease. And the formula is very simple. First of all, this over here, that means percent change. This is a Greek symbol, which means delta. And in mathematics and sciences, it is sometimes referred to or used as change. So that's the percent change. And the percent change is the new value minus the old or original value divided by the old or original value times 100. So it's new minus old divided by old times 100. Why am I multiplying it by 100? Because this is going to give me a decimal value. And in order to change a decimal value to a percent, I have to move 2 places to the right. And by multiplying by 100, I am moving the decimal 2 places to the right. Okay? Now, how does this work in real life? What is this all for? Well, why don't we take a look at it? Okay? If we look here, this is CNN Money. And this is the stock market, my friends. Okay? Right now they're showing the Dow. This is the Dow. Okay? And the stock market, basically, in a nutshell, is a big collection of companies that are selling pieces of themselves to investors like us, like you and me. And you buy a stock for a certain price, and you're hoping that the price of stock goes up. It increases. And the way we measure that increase or decrease is to simply find the percent change. So let's just take a look at a few examples here, okay? When you look over here, the price is what the stock is selling for right now. But if you notice here, it says percent change. And it gives you a percent change. If it's green, it's positive. It's an increase. If it's red over here, okay, it is a negative. It is a decrease. So percent change is used a lot in this world, as you can see. Now, how do we figure this out? Well, let's take a look here. Let's do some examples. Find the percent change of each. Okay, I always like to label things, so my new value is the last value, right? So this is the old value or the original, and this is the new value. And the formula for percent change is new value minus old value divided by old value times 100. So let's check this out. 20 minus 12 is 8 over 12 times 100. This times 100, by the way, I need to put it here because you guys need to understand that you're multiplying by 100 to change the decimal into a percent. But as long as you know you have to convert the decimal to a percent at the end, you don't really need to have that 100 there, okay? So we have 8/12. Let's go ahead and reduce it to make our lives easier. So that's going to be 2/3. We know that 2/3 is 0.666 repeating. So as a percent, we're going to round, and that's going to be 67% increase. Why was it an increase? Because I had a positive value. I had 8/12, so that's positive. How did I go from 0.666 to 67%? Remember, 0.666 rounds to 0.67, and then I got to go 2 places to the right, or in other words, multiply by 100, and when I go 2 places to the right, it gives me 67%. Remember, multiplying by 100 means you're going to move the decimal 2 places to the right. Okay? So going decimal to percent, you're multiplying by 100, you go 2 places to the right. Going from percent to decimal, you're dividing by 100, and you're going 2 places to the left. Okay. So this first one was 67%, and that was an increase. How about number 2? Okay, my old value was 8. My new value is 5. So the percent change in this case is going to equal new minus old over old. So 5 minus 8 is negative 3/8. When I convert 3/8 into a decimal, I'm going to get 8 goes into 30 3 times, which is 24. That's 6. Drop down a 0. It's going to be 7, which is 56. 4, drop a 0. That's 5. So this is the percent change here is negative 0.375, which you have to turn into a percent. So you're going to move the decimal 2 places to the right or multiply by 100. So that is going to equal negative 37.5%. And that is a percent decrease. Why? Because it's negative. Excuse me for 1 second. Okay, we're back. All right, now let's try a little word problem here. Same stuff, okay? It's not a big deal. Don't let the words freak you out. Find the percent change of your stock portfolio from Monday to Wednesday if your stock portfolio was worth $5,250 on Monday and then was worth $3,800 on Wednesday. So this is a real life application. You have stocks and you want to see how much you're gaining by what percent or how much you're losing. So let's try to find the percent change here, okay? Remember, old value, that would be Monday. New value, that would be Wednesday. So percent change is new minus old divided by old. You got to convert it to a decimal, to a percent, so you multiply by 100. All right, let's do the math here. You got 5,250 minus 3,800. Let's subtract. Got to borrow here, make that a 12. It's going to be 4. So I got 1,450. 1,450. And that's going to be negative. Because remember, when you subtract or when you combine numbers with different signs, you subtract as normal and keep the sign of the largest absolute value. So that's negative 1,450 divided by 5,250. Well, I'm going to show you guys a little trick. Instead of trying to divide very large numbers like this, always try to simplify if you can. Whenever you have numbers that end in zeros, you can eliminate those last zeros. Because basically you're dividing 10 from both the numerator and the denominator. So I got this 0 up here canceled with this 0. So now I have 145 divided by 525. Good news. Since they both end in 5, numbers that end in 5 and 0 are divisible by 5. So if I go ahead and simplify this using of course, the methods that we have already learned, okay, by using equivalent fractions, I can divide 5 over 5 to both top and bottom, and I'm going to get 145 divided by 5 is 29, and 525 divided by 5 is 105. Still not the prettiest division in the world, but it's a lot easier than what we started with. So let's go ahead and figure out the decimal value and then convert it into a percent. Now a lot of times these are going to be very ugly numbers, so I'm going to let you go out to 3 decimal places, okay, and you can round to the second. So you're going to go out to the thousands and you're going to round to the hundredths. So let's check this out. I've got 105 into 29. Okay, well, 105 goes into 29 0 times. So I got 29. I'm stuck. What do? Well, I add a decimal, drop down a 0. 105 goes into 290 2 times, which is, sorry, which is 210. And I have 80. Drop down to 0. 105 goes into 800 7 times, which is 735. Okay, and that's going to be a 5. Borrow there, that's 6. Borrow, so that's 65. Drop a 0. And 105 goes into 650 6 times. And remember, all I said was for you to go to the thousands place, which is 3 decimal places. So you're done right here. So you have 0.276. Round these to the hundredths place. So you look at the 7. Okay, that's what you're rounding to. You go to the right number. If that number is 5 or larger, it goes up by a value, and everything to the right drops to zeros. If it is less than 5, the number stays the same, and everything to the right of it drops to zeros. So 6 is larger than 5, so this becomes 0.28. Turn it into a percent, or in other words, multiply by 100, and that becomes 28%. And that is a decrease. Why? Because it was negative. From the beginning, it was negative. Okay? Negative. So whenever you have a negative percent change, that is a percent decrease. Thank you very much. I hope you enjoyed this and learned something. Good luck on your own practice homework. Take care. Bye-bye.